Hey, grade fives. Today we come to the end of area. All right, so we're just going to walk you through the second, or I guess part two of this lesson about area. Your goal for today is a little different from yesterday. So yesterday we taught you how to calculate the area if you were given the length and the width of a rectangle. Today we're going to just switch things around, and your goal is I can calculate the missing side length of a rectangle if I'm given the area and the other side length. All right, so yesterday our questions would have looked something like this. Area equals length times width. We're given the length down here, we're given the width of the rectangle here, and we would simply multiply these two numbers together. 2 times 4 gives us 8. We also talked about the units for area, so it wouldn't be 8 centimeters, it would be 8 centimeters squared. So just to give you a little bit of a visual of what that looks like, yesterday our missing value was A. We didn't know the area. That's what we tried to calculate, and they gave us the two green values here, the length and the width. Today, we're going to switch things around. Today, it's going to look a little something like this, where we're going to give you the area now instead, and the missing value is going to be either the length or the width. Okay, so I'm just going to rearrange my page here just so I have a little bit of room to work to show you how to do a problem like this. So there we go. We just shuffled things around. And now what I want us to do in order to solve a question like this is we're going to take the two values that we know. We know that there's an area of 8 centimeters squared, so we're going to plug that in here for the A. We also know that it has a width of 2 centimeters, so we're going to plug that number in for the W here. And we can do that on the line below. So that's going to look something like this. 8 centimeters squared equals our missing length times 2 centimeters, okay? Now, this actually now looks a lot like algebra, right? When we were talking about algebra, we had a variable or some number that we didn't know, and we learned how to deal with that if we were taking this variable and multiplying it by a number to get another number. So what we learned to do in that situation is we want to use opposite operations. So right now, L is being multiplied by 2, and to get L all by itself, or to solve for L, we wanted to use the opposite of multiplying by 2, which is dividing by 2. So if we put a little line under here to show that we're dividing the right side of our equation by 2 centimeters actually, we would also have to show that we're going to divide the left side of the equation by 2 as well. That's one of the principles we learned about in our algebra unit. Whatever we do to one side of our equation, we must do to the other, okay? So hopefully this is all ringing some bells for you. It's coming back to you. And then what I taught you is that this times 2 and this divide by 2 on the right-hand side of the equation just cancel each other out. And that's perfect because then all we're left with is our L, the length. And that's what we're trying to solve for, right? So that's going to look like this. We've canceled out the 2's on this side. We're left with our L. And then when we do the math over here on the left side of the equal sign, 8 divided by 2 is 4. And because that is a measurement of length, the length of a side of a rectangle, we're back to centimeters for units, all right? Not centimeters squared, because this is a one-dimensional measure. It's also probably worth pointing out, now down here at the bottom in green, highlighted in green here, I just have it, so we've taken our unknown value, or our unknown length here, and plugged it back into the equation here, along with the value we did know here. And if we do go 4 times 2, we can check our answer and make sure that, yeah, that in fact does give us our area of 8 centimeters, okay? So you don't have to do this step down here, but it is definitely worthwhile to go back and check your answer if you were to plug this value back in for a length here. Just check it out with these numbers here to make sure everything balances, okay? So there, example 1, done. Now I'm just going to walk you through one more example. I'm not going to do the fancy presentation way where I've already pre-programmed everything for you. I'm going to do it the dirty way here where I actually go through and solve the problem for you with a pen tool, okay? So this question says, what is the width of this rectangle that has an area of 21 centimeters squared and a length of 7 centimeters squared? So it's always a good idea to start with our formula written down on our page here, area equals length times width. And then we want to plug in the values that we know in the question. We know that the area is 21 centimeters squared. Okay, they've also given us the width. So we'll just write our equal sign in there. sorry, they've given us the length here, and the length is 7 centimeters. So we can plug that in for our L, because that is a length that we know. But what we don't know is the width. So we'll just write times W, because that's our variable we're trying to solve for here, times W. Okay. Now the next step here is we want to solve for W. We want to get W all by itself on this side, on the right side of the equation. And so to do that, what's the opposite of multiplying by 7? Because that's what we're doing. That would be divide by 7. So I'm going to show that here, that we're dividing this side by 7. But of course, with algebra, whatever we do to one side of our equation, we must do to the other side. All right, so I'm showing you this because I actually want you to do these steps when you're doing your work, okay? And then the next thing that we did there is we canceled out this on the right side of the equation. Our 7 times 7 and the divide by 7 cancels out. And all that does is that leaves us with a W on the right side of the equation, which is great because that's what we're trying to solve for, figure out what W equals. And then over here on the left side of the equation, 21 divided by 7. And I know that 7 goes into 21 3 whole times. So that means that the width of this rectangle, the width of this rectangle is 3 centimeters. Okay. And again, we can use this number that we just solved for, and we can plug it back into our initial equation when up here, if we go 7 times 3, we should get an answer of 21. So yeah, everything checks out here. Just to let you know, guys, if I were to mark this on an actual assignment, which I will be doing on the assignment you're turning in, you would get a mark for writing your equation. A equals L times W. You don't have to have it color coded like I have here, but you do have to write out A equals L times W. And that's a very, very easy mark to get. The second step would come from like putting in the values that you know. So putting in the 21 and the 7 here and just leaving the W as a W. So that would get you a second mark. Showing your work. And then the third mark would you'd get that from getting the correct answer here with units. Okay, so we definitely, if the question is asking us in centimeters, then our answer should be in centimeters as well. If the units over here were miles, we would want to put miles over here in our answer. All right, so that's where your 3 marks come from. Mr. Mueller got 100%, 3 out of 3 on this question here. And that's it for your lesson for today, guys. So congratulations. This week we have covered perimeter and area of rectangles, and that was the learning goal for the week. So tune in tomorrow. We'll have a little bit of a different activity for you just to kind of review these concepts and hopefully have a little bit of fun with it, all right? Have a great day and good luck on your assignment.